Welcome again. Today we start our next topic on digital design course, Programmable Logic Devices, PLDs. Programmable logic devices are integrated circuits that contain an array of AND gates and another array of OR gates. There are three kinds of PLDs based on the type of arrays, which has programmable feature. Programmable read-only memory, known as ROM, programmable array logic, known as PLs, and programmable logic array, PLA. The process of entering the information into these devices is known as programming, and here the term programming refers to hardware programming, not software programming. We first start with ROMs. ROM is the memory from which we can only read but cannot write on it. This type of memory is called non-volatile. The information is stored permanently in such memories during manufacturing process. There are several applications of ROMs. They are used to store instructions that are required to start the computer. These instructions are called bootstrap program. They are also used to store firmware, which is a software attached to the hardware or programmed on a hardware device like a keyboard, hard drive, video cards, etc. It's stored in the flash ROM of a hardware device. It provides instructions to the device, communicate and interact with other devices. Here is the general block diagram of ROM. It has N address inputs and M data outputs. The address is applied to ROM address register, which is just a decoder of size N to the power N. So the size of the ROM is 2 to the power N locations, each location of size M. There is only one control signal applied to ROM, which is the read signal, and no write signal like in RAM. So if the ROM size is 1 kilobyte, meaning 1024 locations, each location of size 1 byte, then we need 10 bits to address any location, and the ROM output is of size 8 bits. The address is used to select a ROM location and transfer its contents to the output. In the internal structure of a ROM, we have two basic components, decoder and OR gates. For example, let us store the following table of size 4 by 3 for locations, each location of size 3 bits for simplicity, in a ROM. Since we have 4 locations, then we need 2 bits to address each location, so the decoder size is 2 by 4. In each location we have 3 bits, so we need 3 OR gates. This is the output, and here we have the address. Program the ROM to store the given table. The first column is 1010. So we burn this wire and this wire. The second column 1001, and the third column 0001. Really, you can do it row-wise. In this case, as you see, 110. So here 110. The second row 000. Third row 100, and the last 011. For example, if we apply the address 10, so we'll have here 1 and all the other outputs of the decoder zeros. This one is transferred here, and it is 0 here, and here 0. So this is the out, and the address of this location 10 is read to the out as 100. In this way, during the manufacturing process, ROM is programmed to store the desired contents. ROMs can be used to implement any Boolean function. For example, if we have the function f of three variables a, b, c, and the function equals the sum of min terms 0, 2, 4, and 7. Since we have three variables, then we need 3 to 8 decoder. As you see, 8 outputs. We need only one OR gate for the function. We apply the variables a, b, c to the decoder 0, 1 to 7. Here the function is the sum of min terms 0, so we do not burn here. 1 is not part of the function, 2 is part, 3 is not part of the function, 4 we burn 5, and 6. Here we have the function f. In the future we will draw just one line and mark on the outputs connected to the OR gate, like in the following example. For example, this is a ROM to implement two functions, A and B. A sum of min terms 5, 6, 7. So these are connected to the A. Here is the function A. And B sum of min terms 3 here, 5, 6, 7. These are the outputs connected to the second OR gate. So this is the function A and the function B implemented using ROM. There are 5 basic ROM types. MROM, or known as mask read-only memory, PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, EEPROM, electrically EPROM, and flash memories. MROM was the first ROM type, which is hardware device that contains a pre-programmed set of data or instructions. The PROM is usually manufactured as a blank memory, while the ROM is programmed during the manufacturing process. A user can program the ROM using a special device called PROM programmer or PROM burner to write the desired data into the blank memory chip. The memory can be programmed just once after manufacturing by burning the fuses, which is an irreversible process. In erasable programmable read-only memories, the contents of ROM can be erased and reprogrammed. Electrically erasable and programmable read-only memory is similar to EEPROM, but the ways to program and erase are done by exposing it to an electrical charge, so no transparent window is needed. Flash memories are modern type of erasable EEPROMs. Flash memories can be erased and rewritten faster than ordinary EEPROM. In addition to the above types of ROM, there are other types of ROMs, including optical storage media, such as CD-ROM. Next, we move to programmable array logic, PAL. Here we have array of AND gates and array of OR gates. In ROMs, we program the output array of OR gates. Here we program the AND array, and the OR array is fixed. This means that each AND gate has both normal and complement inputs of variables. So based on the requirement, we can program any of those inputs and hence generate the required product terms by using these AND gates. The inputs of OR gates are not of programmable type. So the number of inputs to each OR gate will be of fixed type. Hence, apply those required product terms to each OR gate as inputs. Therefore, the outputs of PAL will be in the form of some product form. For example, to implement the Boolean functions A and B given this form using PAL. As you see, to this AND gate we apply XY, here X and Y. To the second we apply X and not Z. To the third, X and not Y. And to the last, YZ. Do you see X not Z is common, so we do not need to generate it twice. First OR gate we apply XY, X not Z, and to the second OR gate we apply X not Z, X not Y, YZ. So as you see, the inputs of the AND gates here are programmed. The third type of PLDs is a programmable logic arrays, PLAs. In PLAs, both the inputs of AND gates and the inputs of OR gates are programmable. So this is the most flexible type of PLDs. Here, only the required product terms are generated. For example, to implement these two functions using PLA, we apply to this AND gate XY, and here X not Z, here X not Y, as you see, and here Y Z. Now we apply to the first OR gate XY and X not Z, as you see here, and to the second OR gate X not Z, X not Y, YZ. Programmable logic array is more flexible than programmable array of logic. Thank you.